Welcome to the course of Introduction to Rail Transportation. In this lecture, we will give a general description of electric railway power supply system. We are going to cover the following aspects: electric railways, electric railway power supply system, direct current and alternating current. It is amazing that electricity has thus been used in electric railways. We can know from the animated cartoon how exactly electricity transmitted to power railway trains of different speed. Electric railways. Locomotives were firstly powered by steam, then by diesel, and now by electricity. Electric railway refers to the railway that obtains electric energy from external power source and traction power supply system, and holds the train running through electric locomotive. It includes electric locomotive, maintenance facilities, traction power supply system, various electrical installations and corresponding railway communication, signal, and other equipment. Electric railways can be classified in the following ways: main types of power supply conductor, third rail, conductor rail, overhead contact system. Main types of power supply: DC power supply, AC power supply. Instead of an engine, an electric locomotive is powered by an external electrical power system via traction power facilities. Let's learn about the traction power supply system of electric railways. Electric railway power supply system. It's a set of systems by which electric energy obtained through the electric power system is transformed and switched and then transmitted to the electric locomotive. The traction power supply system of electric railways mainly consists of two parts: traction substation and overhead contact system, OCS. Traction substation. The substation is located near the railway line. It carries current from the power plant over the high voltage transmission lines to the catenary, that is OCS, above the railway. The primary function of TS, traction substation, is to receive the 110 kilovolt three-phase alternating current from the electric power system, convert it into 27.5 or 55 kilovolt single-phase electricity via a traction transformer, and then transfer it to the OCS via feeders by single-phase supply. The change of three-phase alternating current to single-phase in power system is realized by the electrical wiring of traction transformer. A traction substation is usually equipped with two transformers to realize dual power supply. Thus, to promote traction power supply reliability, to improve the electric power quality of the power supply system, and mitigate the effect of traction load on the electric power system and communication lines. A TS adopts both series and parallel compensation. Overhead contact system, also called catenary. Catenary, OCS, is the equipment for direct transmission of electric energy to electric locomotive, hanging over the tracks and from which pantographs collect current. The OCS is the main structure of railway electrification project, and it is a special form of transmission line which is set up along the railway line to supply power to electric locomotives. It is a common sight along the tracks. It can also be seen as the artery of electric railways. OCS comprises contact lines, support structures, registration assemblies, and poles. OCS mainly includes the following content: foundation members, such as cement poles, steel poles, and other bases that support these structures on both sides of the tracks, are all categorized as fundamental components. Foundation mounting parts mainly connect OCS wires with fundamental components. OC wires confer the electricity to electric locomotives. And also, we can see other auxiliary components, including return line, additional suspension, and so on. Now let's come to the third part of the lecture: direct current and alternating current. Traction power supply system includes DC system and AC system according to the OCS current system. Traction power supply system of China's electric railways has adopted the single-phase power frequency 25 kilovolt AC system from the very beginning, which is conducive to the development of electric railways in the future. Direct current. Railways must operate at variable speed. Until recently, this was only practical with the branch-type universal motor, which operates best on DC. For this reason, most early electrified railways used DC, and many still do, particularly rapid transit and trams. Speed was controlled by connecting the traction motors in various series parallel combinations and by inserting and removing starting resistance to limit motor current. This is mainly for speed control. Alternating current. Railways and electrical utilities use AC for the same reason: to use transformers, which require AC to produce a high voltage. The higher the voltage, the lower the current for the same power. Lower current means lower line loss In all, the ability to use lighter and less expensive conductors. Because AC implies very high voltages, it is only used on overhead wires, never on third rails. Inside the locomotive, another transformer steps the voltage down for use by the traction motors and auxiliary loads. Through learning of this lecture, we have understood what electric railway is, learned electric railway power supply system, grasped what direct current and alternating current are. We need to master some basic related words and expressions of electric railway power supply system. Want to know more about China's rail transportation? Stay with us till next time. Thank you.